Okay, everyone, so we are live. Hello. We are going to cover some database today, as well as a topic called LINQ, Language Independent Query. And so in this video, what I'm going to do is I'm going to, from scratch, I'm going to create a database. I'm going to create a table, and I'm going to use LINQ to do CRUD operations on that table. And so let's get started. I'm going to put this in one of my repositories so that you can pull this down for reference. After I'm done, you do a pull on my repository, you'll get my code. Keep in mind, when you create a database on a local machine and then you put that database out on the internet somewhere, be it GitHub or another server, maybe you put that database somewhere else, the code has to change to connect to that database. When it's connecting to my database on my local PC, the application connects to the database locally. There's a connection, like credentials, privileges, that has to be made between the laptop that I'm on and the database itself. If I change that from my laptop to another machine, another server, another computer somewhere, you have to change that connection so that the application still has permissions. Basically, you have to change settings. You have to change settings, what's often called a connection string. For the application to connect to a database, there's a connection string, which is just a connection credentials. It's just username, password, location. Locally, the location is on C:\\, give it a file path. Well, if I take that file path and put it on another machine, the odds are that file path doesn't exist anymore. So you have to not only change maybe username and password, maybe you have to change the file path. And so what I'm getting at here is that my connection from my database, my application to my database, if I put it up on GitHub and you pull it down, there might be some settings that we need to adjust to get this to work. However, you can still reference my code, come back to this video, and see the connection and how it works locally. That's what's going to be important for everybody here, is that you can get this working on your local laptop, just like I'm going to demonstrate in this video. You do not have to get this to work anywhere else besides your laptop. Okay, so that's the important thing. All right. Now, I've gone through in a prior video the steps to create a database. And I'm going to take those steps again because databases are relatively new in this course. And maybe you remember, maybe you don't. And so if we remember, ultimately the database here is called Rankin. And I'm going to make another one. I'll make a database with a customers table. Doesn't really matter too much what the entity is. Inside of Rankin, we had students, And so I'll make a new database. So you right-click Data Connections here. And this is where you have to tell it, okay, yeah, I've got a version of SQL Server running on my machine. The name of that SQL Server is local DB. Now, I was able to find that somewhere else. To get the name of your SQL Server version, I'm going from memory here, but I think it was under Data Sources. No. Once you do it one time, the fact that I've done this once already is kind of a cheat, because I've got the answer right here. But if I haven't done this already, the answer to my question, in other words, what's the name of my version of SQL Server? Well, the name of my SQL Server is localDB, and it's running on my laptop. That's the name of this laptop. So the syntax is the name of the laptop / the name of the instance of SQL Server. And so if you followed my prior video, that should work. Now I'm just going to, this will be my sales database. Watch it error out. I say it'll work, and we'll see. A lot of work going on in the background, so it does tend to take a little bit. Okay. Maybe sometime you put that in parentheses. I remember the window now. If this doesn't work, I remember the window where I was able to find this. So that's okay. I need to show you the original, how I found this server name anyways. Pretty sure I did that in the last video, but it's been a couple of weeks, so kind of forgot for a second. Tick, tick, tick. There's a window called SQL Server Object Explorer. So to find that window, you click on View, and there's your Object Explorer. That pops up. There we go. There we go. This is the name that I'm looking for. If I right-click and rename, I actually have 2 instances of SQL Server running. So it's kind of like running 2 instances of Excel, right? So you open up 2 Excel instances. Like right now, I got 2 instances of Visual Studio running. But the one that I'm going to use is called localDB. You might have both of them, you might have one of them. Either way, you should have, if you install Visual Studio and you just check, Windows applications on the installation package, this comes for free. You don't have to pay for this. Just, this is just automatically installed on your machine. If you install it if you install it the way that we've all been instructed to install it. So let's create a new database. Now let's paste in what I copied from that Object Explorer. Hey, that was a lot quicker. So it kind of gave me a name here that didn't work. So you got to go back into that Object Explorer, expand your SQL Server instances, and there you go. There's the answer to that question. So let's pin this window. Let's go into my sales database. And let's go into the tables and let's add a table. So what we're looking at here is what's called a table designer. And so it allows you to either modify the SQL or it's going to give you a nice little graphical interface, a nice little GUI. So I'm going to have a customer ID. These are your data types. Remember that our tables have data types. And these are important, but for the most part, customer ID obviously is going to be an int. And I'm not going to allow nulls. Obviously, you could check or uncheck that. Obviously, see it's changing the SQL code down below. We're not allowing nulls. Another really common thing to do on your primary keys are to go to the properties. I highlight the property. Here's our customer ID column. And very commonly, you set the customer ID to be the identity column. And what that does is that forces each row to be a unique row by setting it to be the identity. So setting it to be the primary key and identity is what we're looking for here. Now going back to the customer ID column, you'll also see that our customers are going to start with customer number 1 and they're going to go up by 1 each time. Now for our first name column, if you look at the data types, first name is going to be a string in C#. And you could set an nchar. So chars it'd be like a char with 10 characters. And what the n means is that it is Unicode. And what Unicode is an encoding system so that every one character takes up 2 bytes of information. And so being that every character can have 2 bytes worth of information, there's 56,000 different characters that are possible in Unicode languages or in Unicode systems. So with 56,000 some odd number of characters, that Unicode is an encoding system that supports every language of the world. And so ASCII, on the other hand, is an encoding system that's 1 byte per character. And ASCII supports English and maybe a couple other language, but at the end of the day, there's 256 characters in ASCII. And so Unicode is basically, if you need multilingual support, you need an application that supports Unicode, bilingual support. So that's what the N means, is that hey, this for every character takes 2 bytes because it's Unicode. Char versus varchar. Varchar means, okay, we've got 50 characters, but if you only use 10, then use 10 spaces instead of 50. You can store up to 50, but variable length means that you're not wasting space. If you've got just char 50, you're always using 50 characters. Or in other words, you're always using 100 bytes. Varchar means, okay, you could store up to 100 bytes of 50 characters, but if you only type in 5 characters, then just use, 5 characters, 2 bytes per character, use 10 bytes. So varchar is variable length. And then nvarchar is variable length characters in Unicode. So that's a good one. And then max says, okay, let them type in as many characters, if they got a really long first name, nvarchar max. Just let them type, it's variable length. They can type in as many.
Hey, Mr. G, you're breaking up pretty bad. I don't know if you want to switch to your data on your phone.
Yep.
It's breaking up a lot more lately.
Okay, I just switched my Wi-Fi connection. Can you guys hear me better?
Yeah, I give you 100.
Cool. How long ago did I glitch out?
It started maybe like 5-10 minutes ago, but it just got a little bit worse. It was very bad.
Okay. The short version is a really flexible thing for strings is nvarchar max. There's a lot of options for strings in SQL, but a really flexible one is nvarchar max. So I'll store something like first name in this flexible data type on the server. Now, in the real world, you might not want to be so flexible. There's some reasons why that might not be the case, but for this class, it's not a database class. We're just focusing on the basics. So let's say a customer has an ID, first name, last name, and let's just say they have a budget. So we'll set it to be the money data type in SQL. We'll get it into a C# decimal. Now, one thing here with money is I'm anticipating that money can accept dollar signs. And so again, I'm just thinking a little bit ahead. If I'm taking this money out of the database, it's got a dollar symbol in it. We're going to have to parse that dollar symbol out. So let's just make it a decimal. And oh boy, this 18,0, I got to refresh myself what those numbers mean. Let me look at some other. Obviously, we could do float.
I remember doing something in one of the assignments where I rounded off 16,2. What was in there? Decimal 16,2.
Yeah, I think in your C# code.
No, it was in SQL.
Okay. Yeah, I kind of forget what those numbers mean right now. I'm just thinking for compatibility, maybe we'll just put it in a float for compatibility right now. Okay, put it in a database float and we'll read it in a C# float. Get rid of the allow nulls. So pretty simple table here. Now we haven't run this command, right? This is kind of like setting up our template, but we haven't run it. So to run it, you got to click this update button. And before I click update, it says create table DBO. Okay, I want this table to be my customer table. So there might be a way to change the name of the table through this GUI, but the easiest way that I found is just change the SQL. DBO stands for database owner, and so that's the default schema. We haven't really covered schemas, but safe to say just leave that alone. We can generate a script so we can run this later, but let's just run the database command now. Okay, we get the nice little green check mark that says completed. And if you look here, sometimes you got to refresh this to get this customer table to show up. But we do have our customer table. You can now close this. If you ever need to come back.
Where's that update button?
The update button was add new table. The update button's right here, where my mouse is. That's how you actually run the SQL code to create the table. Now again, real world, you're going to have many tables. You might have 15 tables on the low side. You might have 100 tables on the high side. We're keeping it basic for this first time. If you need to modify a table, you can open the table. Like, let's say I want to change something. You right-click the table and open the table definition. Then you can come in here and maybe you want to change this to decimal. And then you click on update. Now, I'm not going to do this, but let's just say when you're creating the table, you make a mistake. Okay, try not to do that. Try and just make it right the first time. Again, you might not do that. You might need to update it, but it's in your best interest to not change the table definition once it's been created. Another thing is, if you modify something here and then you go to close this window, it's asking you if you want to save the .sql file. The .sql file is the code right here. It's not asking you if you want to save the table itself. It's asking you if you want to save the SQL. So be aware that what you're saying here is, no, I don't want to save the SQL code, which the SQL code is this create table. It's not like if I say no here, it's like the table goes away or anything. Table's still here. So an easy way to get data into the table at this point, you might want to load your table up with some basic what you call seed data. Is just right click the table, show table data, and then you can just type right here. And keep in mind, customer ID is your primary column. It's automatically going to give it the number of 1. And you can type it in. Now, we can use the application to insert data, and we're going to do that. But just for some seed data, now we have 3 customers that we've inserted. And so we've created a database, we've created a table, and we've inserted some dummy data or some seed data into our table. Okay, now to get into LINQ, I don't have slides on LINQ. Last week we spent a week studying SQL, Structured Query Language. SQL is a standard, but there are at least a couple of versions that have been derived of SQL. The main players that I know of are Transact SQL, are called T-SQL. T-SQL is Microsoft's version of SQL. So when you're working with a C# application, you're oftentimes, if you're going to use SQL, you're oftentimes writing transact SQL. We've learned transact SQL. In another database environment, if you're not using Microsoft's databases, another big player is Oracle. Oracle is actually, there are more Oracle databases in this world than there are Microsoft databases, to the last of my knowledge. If you're interacting with Oracle databases, you're using a flavor of SQL called procedural language SQL, oftentimes called PL SQL. Transact SQL and PL SQL are similar, but they have a lot of differences. And so you have these different versions of SQL, and it's once you learn vanilla SQL, you can then specialize in either one. You get familiar with either PL SQL or Transact SQL, and so they were supposed to be some smart people came up with a way of saying, okay, well, if I'm writing Java and my Java application is connecting to an Oracle database, then I need to learn this PL SQL. And if I'm writing C# and my C# connects to a Microsoft database, then I need to learn this Transact SQL. Like, let's make a unified way that regardless if I'm writing Java or regardless if I'm writing C#, or maybe I'm writing PHP. PHP, connects to a MySQL database. And so you got these different flavors of SQL that I got to learn. So maybe let's make a way that is independent of the language. So that's where they came up with that search didn't work. How did I end up on Google Scholar? That's what LINQ is. LINQ is a language, I say independent, integrated. Learned something new. Or I forgot. Now I remember. Language integrated query is a uniform query syntax. It says in C# and VB, but other languages as well, to interact with databases. And as a developer, here's us, the smiley developer, we can use LINQ to query our SQL database. And so that's what we're going to do. Directly, you can use SQL, as we've been learning, but you're going to find out that LINQ is actually quite similar to all the SQL commands that we learned last week. So in our C#, we're going to write LINQ to work with our SQL database to do the CRUD operations. Now, in order to get this to work, I had to rerun the downloader for Visual Studio, and I had to install an additional item. So let me run this downloader. Give me 1 second here, go into my downloaders, into my download. You kind of see here, a long while ago, I installed Visual Studio Community. So I still had the installer file in my downloads. I didn't have to go back out to the internet to get the installer. I'm going to close Visual Studio temporarily because the installer needs it to be closed. And so all I'm doing here is I'm installing an additional template that I'm going to need to get this to work. It's just an additional checkbox. I actually have two versions of Visual Studio on this laptop. So obviously 2019 is what currently using. So I'm going to modify the installation package by clicking this Modify button. And you can see here that this is basically all that I asked you guys to check. When I had you install this on the first day of the semester, you just say, okay, click this button and install all that. What was not checked was this link to SQL tools. So if you guys go back into this installer, one thing that you'll need to do is under individual components, come back into here and click link to SQL tools. That should not be clicked for you. That should be unchecked. If you check that, it'll give you an option to install that button over here. Obviously, if let's just say Get for Windows. If I check that, then I click Modify. But I'm not going to do that now. Since nothing has changed, I'm just going to click on Close. You're going to click on Link to SQL Tools, then you're going to click on Modify button. And then it's going to download and install, and then you'll have what you need to do this. Since I've already done this, I've already installed it, I'm ready to go. Reopen that. I think someone told me a while ago. Is my connection doing better now?
Yep.
Good. Okay. So now that I've installed the necessary tools, I'm going to add a new item. And let me find what I'm looking for. Here we have a link to SQL class. This will be here if you've installed the proper item. If you didn't install that option, this is going to be missing. And you'll notice the file extension is called DBML. So I'm just going to give this the name of my database, which was sales. So we're going to add this new file for the sales database. And you can see here it added some different references. We don't need that open at the moment. And here's our new file, this DBML. And you can see it opened up this DBML file. The Object Relational Designer allows you to visualize your data classes in your code. So what it will have on here are classes, just like we've created a student class in the past, and we've created all sorts of classes, and then out of those classes we create our objects. And so it says create data classes by dragging them from Server Explorer or the toolbox onto this design server. So in our Server Explorer, pop that open. lost my sales. Now, I don't know if this is, I think this has happened to you guys before. What's happened is I've got two instances open and I added my sales over here and it's not over here. You can always reconnect it, but I'm just going to switch these windows around. In other words, if it's not here, it's just not showing. There's a process that we can take to re-add it. Add a connection. SQL Server. You have to give it the name of your SQL Server, which, oh good, it's still there. And then there's my sales. Okay, so either way, it's on both windows now. Should not matter. Close this. Get myself organized just a second here. Okay, so what I do now is I browse to my sales database, I find the table, I drag and drop. What's actually being created here is a customer class. And in that customer class, we have some default properties. There's a property customer ID, first name, last name, and budget. So we are creating a class from a database table. That's often called database first design. You create the database and then you create your classes around the database. You'll wind up using a combination of, well, there's only going to be one class from the database, and then you'll continue creating classes like you know how. If I want to create another class, just add another class, and these classes can all interact and play nice together. But we add this customer class from our customer table that gives us a customer ID property, a first name property, last name property, and budget property. You can see we can add relationships, we could add more properties, and there's a way to create methods on this class as well. So if I just save that, I now have this sales DBML file that I can interact with in my C# code. So we're going to use LINQ to read our customers and then put our customers into the form, maybe into a label. Now the object that we need to instantiate to make a connection to our sales, it's kind of a funny object name. This is, here we go. One second. I might be missing a step. I'm missing a step. I'm not remembering. It's a good time for a break because I need to remember this step that I forgot. Let me pause the video. Okay, we are back, and as the nature of these things go, when a human being makes a mistake, it's their first nature to go, it's not something I'm doing, it must be something else. It must be a step I forgot. It's not like I'm making a mistake with the code. I'm writing the code just fine. Not a problem with my code. Many times it's the problem with your code. It was simply, I was typing in an area between the class and the namespace. You can't put code there. That's a no-no. You put your code in the class. And once I sat back down and looked at the problem, solved it pretty quick. Anyways, so what I just created, if I type in the word data context, it's going to suggest the name of my DBML file, which is sales. So sales data context. So we're going to reference our sales database through this sales data context object. And I can call this sales table. So we're going to get into the sales table through this data context object. And when, to write some executable code, when the form is loaded, we're going to go into our constructor here. This form is called form1. Obviously, I can rename that, as you all know. I'm going in here and saying form sales. There we go, form sales. Now we're in the form sales constructor. And this is where, you could write this code on different button clicks. Obviously, you don't have to do this in a constructor. It doesn't make sense to do it in a constructor. You might wait to do it on a button click, or you might do it in a constructor. That all, I'm just showing you the basics, and where you put this code is going to be dependent, obviously, on how your application runs.
Hey, Mr. G, I got a question. That sales data context, is that the name of the DBML file plus data context? So if it was called cars.dbml, it would be called cars data context?
Correct.
Okay, thanks.
You got it. So now we're going to write some LINQ. And so all I'm going to do is use LINQ to query the sales table. And you're going to find out LINQ is pretty similar. In SQL is select, from, where, order by. These same keywords exist. They're just in a different order in LINQ. And so I'm going to store what the query returns in a var. It's very common in LINQ to use the var data type. You don't know what it's going to return. In this case, it's going to return some students. I guess I could return, I suppose, it doesn't even recognize, oh no, I don't have student, I have customer, right? Getting my classes crossed. So we now have the customer data type because we put it into our file. So it does recognize customer. So I could store this in customer, but pretty commonly you store LINQ results in a var. So I'm just going to say, okay, var results equals sales table Um, it's not sales table. It's a bad name. It's a sales database. Let's rename that. Sales database. Sales database, customers table. So all this is, this customers is, our table is singular, and customers is the idea is that multiple customers are going to be inside this customer table. So it makes our table name plural. So here's our select method, and the syntax for this is a little strange. This is kind of like a select star. This is the equivalent of select everything. Select, and S is a made-up variable name. I could call this X. Okay, and we're going to wind up using this made-up variable name in our where clause. But I'm just going to choose S, maybe C for customer. It's kind of like a select star. And we're going to do more with this, where we filter our results. Instead of selecting everything, we're going to select where a condition exists. But this is a LINQ syntax, as simple as it gets. Once we have information now stored in this variable, let's go ahead and create a list of customers. Now, doesn't like my list. Probably need to import LINQ. We got a LINQ here. We need our collections generic. So all I'm trying to do is make a list.
Does the class actually show up as a class form, or is it kind of hidden?
Well, now it's being recognized. Give me 1 second there, Daniel. I'll answer your equals.
You're missing a name for the list.
You know? Thank you. What was your question, Daniel? Could you repeat that if you heard me, Daniel?
Oh, I was just curious about the class. I guess that when you drag and drop, then it forms a class with all of the properties and everything in it. But I don't see it over there in your, solution explorer. So
Yeah.
I was just wondering about, like, if you wanted to modify properties of this class, you have to go through the table and change the table and then redrop it or something.
That's one option. Or you can modify it through this GUI. Here, add a property, so on and so forth. Yeah, you could modify it through the table or through this DBML. I think I would take your approach, which is to modify the table first and then redrop it. Okay. Obviously, our list has to have an identifier. I'd say it's Monday, but it's Tuesday. So now our 3 customers worth of data are stored in this list of customers. And we can loop through for each customer C and customers. I guess we can just throw a label on here. Go back to my toolbox. And this isn't going to be the cleanest code ever, but it's going to get the job done. Which is demonstrating how this all works. And because C is a customer, we could say C dot first name plus C dot last name. We can format it. This is all going to be done when the form loads. We're going to run our little query here. We turn the result of that query into a list of customers, which is common, right? So if you have a table and a table has a bunch of rows, each row becomes one item in the list. And that's kind of the connection that you have to make in your mind is you read the data out of the table and each row becomes one customer in the list of customers. And then we can loop through those customers, print them out in a result label. And we now have the data that's been read. Now, we could say where I'm going to pause the recording. My syntax is a little rough, so I got to look up the syntax real quick. You know, my syntax was fine. So where a customer has a budget of $1,000. So again, the select all the customers from the customers table. Well, here again from a SQL standpoint, you say select from where, and then here is kind of like from where select. So it's the same keyword, it's just different order. And your where condition, where the customer has a budget of $1,000. Select that customer. Now, if we had multiple customers with $1,000 budget, we would return multiple customers, but we don't. Right now we just have one, which is me, right? So the where is a filter. Let's go ahead and
It seems like the where and the select are in opposite order.
yeah. In LINQ it's just a different order.
If it's the other way around, I guess it won't work, huh?
Yeah, it does have to be in a specific order. Let me go ahead and throw in another customer with $1,000 budget and just demo. So you can use all the less than, greater than operators, equal to operators. Now we're selecting those two customers with a budget of $1,000. So that's our read, right? So I'm gonna do all CRUD operations. So create, read, update, delete. And here's our read. Now in insert, obviously we need some controls for that. And on your application, you'll have controls for your insert. But, you know, at this point, you should know how to read the information off of the controls to create an object. And so, you know, I'm gonna shortcut that because we all know how to do that. Customer, new customer equals I like to use the keyword new inside of my identifier. Let's say first name equals. Now the thing about this create is that this is going inside of a constructor, right? So every time we construct this form, it's going to insert this information. So I'm going to end up with a lot of the whatever same repetitive customer name. I don't even remember my customer names, so I'll say Betsy. Comma. There we go. Oh, now data type problem, right? Budget isn't a string. Notice it took budget and put it into a double. So the data type in the form was a float, and C# decided, let's go ahead and put that up into a double. So that's good. That works. And so, you know, in your applications, obviously you'll read the first name and the last name in the budget off of controls on the form. And the command to insert salesDB customers table insert on submit, and you'll notice that the constructor for insert on submit takes a customer object. So it says, hey, whenever we call this submit method, go ahead and insert this customer. So all we have to do is call the submit method, which is salesDB submit changes.
Hey, Mr. G, got a question here. The Go ahead, Dang. I'll let you go.
Is your table name customer or customers?
The table is named customer. So the automatic syntax is to add a S on the name of your table. Tables are always going to be singular. When you're naming your entities, they're always singular. Notice our classes are always singular. But the customers table, it's assuming there are multiple. There are multiple customer objects inside of the customer table. So that's just a convention.
No, but you're over there on the left. It looks like it doesn't have an S on the end.
That's what I'm saying. It automatically, when you create this sales DB, it automatically applies the S to a customers table, assuming there's multiple customer objects inside of it. So it's just a convention.
I got a question about the constructor line 24 through 29 there. You don't have a separate class for customer, or did I miss that in the Explorer on the side? Because otherwise it would just throw an error because it's not going to know what first name, last name, or is it pull that directly from the table?
Yeah, it pulls it from the table, and when we add the table to this file here, it creates our customer class as well as each column has a property automatically created for it.
So it's like kind of like a quote unquote auto implemented property when we create a table and we use LINQ. We don't have to have a separate .cs customer or .cs.
Yes, that's correct. All right. So this is all being done on, instead of doing this, I'm just gonna cut that out instead of doing that every time you load the form. That seems a little bit much. Let's just do it on button click. Now, clicking this button, and it's not going to do much right now. It's going to insert the data, but you're not going to see it. Like most likely, you would refresh or something and rerun some code. Put a read inside of a read inside of a method and call that method to re-update that label. This is just not going to do that. But I click the button, therefore Betsy should be inserted into our table. And there you go. The Betsy customer is now inside of our table. And let me go back here and just do my select star, and you can see that Betsy's now in my table. If I click that button 10 times, I'd have 10 Betsy Smiths with $4,000 budgets put into that table. So let's make a button for updating Betsy. So we have done our read using LINQ. Our create with LINQ. Now, really what makes this, because we don't have a LINQ query in here, but these methods, they all come with this LINQ to SQL file that we added. So technically there's some going on behind the scenes. Let's update. Now, for an update, what we do is we need to first read. We need to read our customer into a customer object, into a C# customer object. Then we're going to update through the properties of that object. And then we're going to reinsert. So there's not an, like here there's an insert method. There's no update method. You read, modify, and submit changes. We don't have to insert. There's no insert method. We just submit changes. So let's start with the reading. I'm just going to start a little copy paste. So now we are selecting that one customer. It doesn't like that. Darn. No. There might be a more direct way that I can toy with besides putting it into a list, because I know we only have one customer here, so I don't really need the list. So her name was Betsy Smith, and we're going to update it to Elizabeth. And we call submit changes. If that works, you'll get a little message that says updated. Okay, it appears to have worked. And to demo, yeah, I'm missing a step.
Why Sub-Zero on there?
That's the first customer in the list. There's really only one customer in the list because, well, we know that, but yeah, I have a feeling that this is going to insert, instead of modifying Betsy, I think it's going to insert an Elizabeth beneath Betsy. Let me try it. I'm going to take that line out. This is what I had originally. It's going to oh, it did update. I didn't think I needed to. My code was good. It just, the database needed a second. I did not run this program again. I did not click the button update again. Check the tape. The tape will verify me. I did not need to modify any of my code. I did not click that update button again. So I did not need to run this insert on submit. Matter of fact, I'm taking that out. That was not necessary. All I needed to do was read the customer out of the table. I put that customer into a list. Maybe that wasn't necessary. I think... Oh... Because I know there's only one customer with the name of Betsy. I think that would work. That way, since there's just one, and then it would be... There you go. Doesn't like C because I've already... That's better. That way we, because here we're only updating one person. Store that one person in a singular object instead of a list of customers. Just store it in a single customer. Update that person's name, call submit changes, update the GUI, and when we show the table data, what once was Betsy is now Elizabeth in our database. And the reason it initially said Betsy was just a little bit of a lag. And I'm not sure what caused that lag, but if I would have just waited, maybe I would have come back here and 10 seconds later and refreshed this, and it said Elizabeth instead of Betsy. The first time it said Betsy, and so I thought I did the code wrong, but I started messing with the code. I didn't run anything, and then I came back in here and it was Elizabeth. So my update, there's a nice clean update for you. So what have we done? We've read using LINQ. Just as a heads up, your lab for this week, just so you can practice with LINQ, is going to be to practice this piece right here. And so just so you can practice with LINQ until you feel comfortable, we're going to use the Henry database. You already have the SQL answers on how to query the Henry database. Now you're just going to convert that into LINQ. Those same queries from last week on the Henry database for your lab, we're just going to convert those over into LINQ queries instead of SQL queries. And so you'll get plenty of practice writing LINQ. By the way, LINQ has two different syntaxes. I want you to use this dot syntax, dot select, dot where. If you go online and look up some resources, there's also a way to write LINQ that's not using this dot syntax. So just as I'm doing here, all the keywords have a dot in front of them. What do we got left? We got delete. Let's delete Betsy. So the update is now on click. And let's delete. Big button that says delete Betsy. So the delete is going to be really similar in that you have to read a customer object out of, and since the first name can change, a lot of times maybe you read, where the first name is Betsy and maybe the customer ID, you want to delete by something, because you could have multiple customers named Betsy, right? So you want to delete by something that's unique, like maybe the customer ID. And so if I look up customer ID, we're not just deleting by someone's first name, we're deleting them by their unique identifier. So customer ID is 5. So let's delete customer number 5 instead of deleting Betsy. Okay, so we got our data. We query for customer number 5. We select that customer. We convert the var data into a customer object. We cast data into a customer object. There is a delete command, delete on submit. Say, okay, when we call the submit method, let's delete this customer, ID of 5. And then let's call submit. salesdb dot submit changes. I have not clicked that button yet. I'm just getting my delete away from my list. So right now, Elizabeth Smith is there. Just because you delete it out of the database does not mean that the UI has updated. So Elizabeth Smith will still be there unless you refresh that label when you click the delete button. Obviously, you want to do that. If I click it, aha. Invalid cast, cannot convert customer. So it's really not liking that line where I am converting into my customer object. Line 75. Well, then I assume that it would not like this line right here. Even though I assumed that would work, but I never tested it. So I got to bring my list of customers back and then say customers. Okay, this is the typos. This is the code that was working. before I assumed that this code would work. This code did not work as demonstrated here. So let's bring our list back. Okay. I'm sure if I tinker with that for 10 more minutes, I'd find a solution to that. But for now, use your LINQ query, put the results of it into a list, a C# list. Customer 0 in that list we're deleting when we call the submit changes method. Call the submit changes method. Let's test it out. After that, just get a little feedback saying the customer is deleted if it worked. It looks like it worked. And you can see customer 5 is gone. If I reload the form, we no longer have a customer 5. If I create my Betsy customer, I'm going to click this. It did not update the form. I should do that. Show table data. Wait for it. You can see it now skips customer 5. Betsy, the next Betsy Smith was put in at customer 6. We've deleted customer 5. Now, if we run our delete again, clearly our delete's not going to work because why? Because we don't have a customer 5. This is a error that's really coming from the database. It says argument out of range exception. It's telling me on line 77. So if I go to line 77, really the problem is coming from the database. Basically, this list was returning nothing, and so there was no customer sub 0, so there's no customer to delete. And so that's really an error coming from the database, and you would put a try catch around that to handle that scenario in the case that any one of these operations don't work. It's very common to wrap your database operations around try catch blocks to catch the exceptions that are thrown so your program doesn't crash like that. And so now we've successfully completed a read, an insert, an update, and a delete around a single table. And that's something that you will need to implement on your projects. And all that's left for you guys, I mean, obviously you're going to probably reference this video, but would be to practice. And to practice the LINQ, again, what the lab is, and this lab is just for practice, it's not for a grade. The lab is to take the same assignment that we did last week, which was the Henry database. You should have all the answers to this now. And at least for the single table, don't worry about the multi-table because we're not doing LINQ on multi-tables. There's another level of complexity there. But convert these SQL queries into LINQ queries. Okay, and that's just for practice to help you get familiar with LINQ. And so hopefully you found this video useful. I'm going to go ahead and stop recording. Any questions before I stop recording? All right. I need a sign off. I don't have a sign off. Oh well. It's not my day job.